And that one ended when we were trying to send the link somewhere. Okay. Because she gonna send me something. Okay. Hello, we are live now, and we have some questions here already. So if you still want to send your questions in, you can send your question via WhatsApp through this number, and you can use the link to send your number as well. So let's start with this question I have with me here. The first thing I have with me here is a simultaneous equation. So we have 2p minus 3q equals 4, and the second equation is 3p minus 2q equals 9. So I'll label this as equation 1 and label this as equation 2. Now we know that we have two major methods to solve simultaneous equation: the substitution method and the elimination method. So I'll use the substitution method first, and I'll use the elimination method as well. Now, to use the substitution method, what do we do? Now we are dealing with two variables here, variables p and q. The thing we do is we choose an equation. It can be equation 1 and it can be equation 2. So let's choose an equation. We can say from equation 1, we have 2p minus 3q equals 4. Now what do we do when we choose an equation? We'll make one of the variables the subject of formula in this equation. So from the first equation, let us make we can choose any one. Let us make p the subject of formula in this equation. So if we make p subject of formula in this place, then this implies that 2p is equal to 4 plus 3q. Then this implies that p equals 4 plus 3q all over 2. Now, the value of p that we have gotten now, mind you, we got this value of p from using equation 1. So this value of p that we have gotten now, we are going to insert it in equation 2. So we would say substituting p equals 4 plus 3q over 2 into equation 2. Be very, very careful. We used equation 1 to get this p. So we are not going to substitute this value into equation 1 again. We are going to substitute it into equation 2. So substituting this value into equation 2, so which implies that anywhere I see p in equation 2, then I will replace it with this. So let's do that. So we have 3 into bracket 4 plus 3q all over 2, then minus 2q equals 9. So the next thing I do here is, since I have 2 at the bottom here, I can multiply through by 2. Multiplying through by 2. So if I multiply through by 2 here, what do I have? I will have 2 multiplied by this, then that means that 2 will be given off here. So I'll have 3 into bracket 4 plus 3q, then minus 2 times 2q, that will be 4q, then 2 times 9, that's 18. Now, why did I multiply 2 by 2? The reason is because we have a 2 at the denominator here, then I don't want anything to be in fraction form, so I want everything to be in whole number form, so that's why I multiplied 2 by 2 here. So if we have, let's say we have 2q over 3 here, and there's 2 here as well, we just find the LCM of all the numbers that are at the denominator, then we use that LCM to multiply the equation 2. With that, we get rid of any fraction form that we have. Mind you, you cannot do this if you don't have an equation. If you don't have an equation that I'm doing this, I won't be able to multiply through by 2 if I don't have an equation, because it will be as though I'm changing what the equation looks like. But because it's an equation, if I'm multiplying 2 by 2, what I'm doing to the left hand side, I'm doing to the right hand side, and equality still holds. So let's continue with what we have here. So what we do next here is we open the bracket. So we have 3 times 4 is 12, plus 3 times 3q, that's 9q, then minus 4q equals 18. So collecting items here, I think the terms that are having q, they are already together. So we just take 12 to the other side. So we have 9q minus 4q, that's 5q equals 18 minus 12, which implies that 5q equals 6. So at the end of the day, this implies that, so when we divide both sides by 5, this implies that q equals 6 over 5. Now that we've gotten the value of q, remember the other time we got that p equals 4 plus 3q over 2. So all we just have to do is, again, is substitute this value of q that we have gotten into this expression. So permit me to use this side of the board. So if I substitute that value here, I will have p equals 4 plus 3. So q is now 6 over 5. So that will be 3 multiplied by 6 over 5 all over 2. So this implies that I will have this to be 4 plus 3 times 6, that's 18. So we have 18 over 5 all over 2. So this will be equal. So by the time you find the LCM of this numerator here, that will be 5. This is like over 1. So 1 in 5, that's 5. 5 times 4 will have 20. Plus 5 in 5, that's 1. 1 times 18, that's 18. Then everything still all over 2. So by this here, I have 20 plus 18, that's 38 over 5 divided by 2, which is the same thing as 38 over 5 times 1 over 2. And what's 2? How many times do we see 2 in 38? That's 19. So we have 19 over 5, which implies that P is 19 over 5 and Q is what? Q is 6 over 5. So this is we using substitution method. Let us write our answers down. So we got P to be 19 over 5 and Q is 6 over 5. Now, let's try and use elimination method. Let's see if we get the same answer as we have gotten it here. Even though I prefer using elimination method because that makes the work easier. You won't have to be dealing with too much of fractions like this. So, I'll just clean these parts. So, you might want to speed up in writing this part because I'll soon get there now. Now, we want to use elimination method. Elimination as it stands is an English word. That is, you want to eliminate something. And by the time you eliminate something, you are eliminating it so that one can exist. Now we have two variables here. We have P and we have Q. I can choose to eliminate Q so that I can work with P alone. And I can choose to eliminate P so that I can work with Q alone. So whichever one I choose here, I don't have any issue. So let me choose to eliminate Q. Now one of the things you watch out if you want to eliminate any variable is that look at the two equations. From these two equations, does this variable have the same coefficients? Now let's look at Q. The coefficient of Q here is minus 3. And the coefficient of Q here is minus 2. Now let us not consider the sign now. So let's say the coefficient of Q here is 3 and the coefficient of Q here is 2. Which means that the coefficients are not the same. Now, we can do this to make the coefficients the same. Now you check it out. Is there a number that I can use to multiply one of the coefficients? I mean a whole number that I can use to multiply one of the coefficients to give me the other coefficient. For instance, if it will be like 6q and 2q now, if I use 3 to multiply 2, I will get 6. So I won't bother myself to do anything for both of them. I will only do for this. I will just multiply the equation that has this one. I will just multiply it with 3. Then I will eliminate from there off. But in this situation, we have 3 here, we have 3. There's no whole number that we can use to multiply 2 that will give us 3. So which implies that you actually, as you are doing something for this equation, you are doing something for this equation as well. So let's see what we'll do. So the coefficient of this Q here is 2. So I will use this 2 to multiply equation 1. So you say multiplying equation 1 and 2. Now for equation 1, I will multiply it by 2. Definitely for equation 2, I will multiply it by what? I will multiply it by 3. The coefficient of Q in equation 1. So multiplying equation 1 and 2 by 2 and 3 respectively. Mind you, all these story, they are very, very, very important. They are very, very, very important. Why? Because you need to be able to speak to your examiner. You will not be able to your examiner to explain what you are doing. So you need to be writing all these stories. So let's do that. So if we multiply the whole of equation 1 by 2, so 2 times 2, that's 4p. 2 times minus 3, that's minus 6q, equals, then 2 times 4, that's what? That's 8. So we have another equation. You can call this, you can choose to call this one equation 3. Then coming down to equation 2, what are we multiplying by? We're multiplying by 3. So 3 times 3p, that's 9p. Then 3 times minus 2q, that's minus 6q. Then 3 times 9, that's 27. So what I do now is that I want to combine the two equations together. I said the first stage of elimination is to watch out maybe the variable that you want to eliminate if it has the same coefficient. If it does not have the same coefficient, I've already shown you what you do. Now, this stage now, when it is already having the same coefficient, what do we do next? The next thing is to check the signs. Now, for the first and second equation, this is like the fourth equation now. Now, for the equation 3 and equation 4, if you check the coefficient of q here, without considering the sign, we have 6 and 6, which implies that the coefficient are the same. Now, if you look at the sign as well, they both have negative sign, which means that they have the same sign. So whenever you are eliminating and you have already ensured that the coefficients are the same without considering the sign, then now, if the signs are the same, you subtract one equation from the other. If the signs are the same, and if the signs are not the same, then you have, that is, if you have a positive sign and a negative sign, one from the one equation and the other from the other. So in this case now we have minus sign and minus sign, two negative signs. So definitely we are going to subtract. Even if this were positive sign and positive sign, we will still have to subtract. So the only case we have the two equations to eliminate q is when what? When probably we have a negative sign here and we have a positive sign here, or vice versa. So what am I doing here? I'm going to subtract. So 4p, this is like 4p minus 9p, and this is minus 6q minus 6q, that will be equal to 8 minus 27. And by the time you write the result, 4p minus 9p, that's minus 5p. So you agree with me that this will become 0, and this will be equal to, so what's 8 minus 27? 8 minus 27, that should be minus 19. Minus 19. So by the time I divide both sides, divide both sides by minus 5. What do we have? We have p will now be equals to minus 19 over minus 5, which is 19 over 5. Let us change that. Yeah, that's actually very, very correct. So that was what we got when we used substitution method. You can see that this saves time than the other one that we have to be computing a lot of things. So this saves a lot of time. Now, that's that. Now, to get the value of q, now we've already got the value of p, that which is 19 over 5. Now, to get the value of q, all we just have to do is what? Come and substitute the value of p into any of these equations, and easily we'll get our result. So, permit me to clean this part now. So, I can pick any equation I like. Let me pick equation 2. So, picking equation 2, substituting the value of p, so I'll have 3 into bracket 19 over 5. 19 over 5 minus 2q equals 9. Then, like I did the other time, so I'll multiply the equation 2 by 5. So multiplying the equation by 5. So what do I have here? The 5 I'm using to multiply will cancel this 5 out. So I will have 3 multiplied by 19 minus 5 times minus 2, that's minus 10q. Then 5 times 9, that's 45. So what is 3 times 19? 3 times 19, that should be 57. So we have 57 minus 10q equals 45. So I have minus 10q equals 45 minus 57. So minus 10q will be equals to, so 45 minus 57, so that should be minus 12. That should be minus 12. So when we divide both sides by minus 10 now, divide both sides by minus 10. So this goes, then q will become, so there's a common factor here. Minus 2 can go in both of them. So minus 2 in 12, in minus 12, that's 6. And minus 2 in minus 10, that's 5. So if we check now, our p that we got here is 19 over 5, and our q is 6 over 5. Another time when we use substitution method, we got the same result. So which implies that this is very, very, very okay. So that's substitution and elimination method, right? So there are other methods to solve. We have the matrix method, which is the Cramer's rule, but I won't be using that now, except it's required. So that's that about this question. So in case you are just joining us, don't forget you can send your questions as well. The difficult ones, those ones that you don't even have any clue about them, send them in, then we'll attend to them as the class proceeds. So you can send them through this number that is being displayed here. So in the meantime, before we receive other questions, so I'll be picking random questions from the past question and I'll be solving. Now, so I have a question here. The question is on coordinate geometry. The question says, find the equation of line. This question is, I'm taking it from 2019 theory question. 2019 theory question 2a. So say find the equation of the line which passes through the point. We are looking for the equation of the line that passes through these points. Minus 2, 7 and point B, which is 2, minus 3. So we want to find the equation of this line. To find the equation of a line that is joining 2 points, we need some basic things. Before you can find the equation of a line, you need the slope of that line. You need the slope of that line to be given. Now, it's either you are given the slope of the line together with any point on that line. By point, I mean coordinate of a point. So these are coordinates, minus 2, 7, that is, for the x-axis we have minus 2 units, and for the y-axis we have 7 units. So, for this one, for the x-axis we have 2, and we have what? Minus 3. Now, before I proceed in solving this question further, if you have your friends that also want to write WAEC with you, your classmates, anybody, just invite them to join the class so that you won't be the only one enjoying this. So, I can proceed with that now. Now, so as I've described this, if you are given the slope and any point, then you can get the equation of a line. You don't need any other information. The slope and any point is enough. Or you are given 2 points. 2 points. If you are given 2 points on the line, that is the coordinate of 2 points. 2 points. So if you have 2 points on the line, then you can find the equation of the line without any stress. Because with the 2 points, you'll be able to what? You'll be able to produce the slope of that line. So now let us find the equation because we have 2 points already now. We don't need the slope now, but we can find the slope here. To find the slope of any line that 2 points are being given there, let's say the points are point x1, y1, and we have point x2, y2. To find the slope of the line that is joining these 2 points, then the slope that is denoted as m, slope is also known as gradient, is equal to y2 minus y1 over x2 minus x1. Now, for those of you that you are doing physics, you must have heard about slope before when you are doing your practicals. And the amazing thing about finding slope is that your instructor will tell you choose any 2 points on the straight line graph that you have gotten, and your result will still be the same. Choose any. So which implies that these 2 points are not the only 2 points that I will use this formula for and I will get this slope. I can still use some other points. That is why there's a general form of this formula which can be written this way, that is choose any. So let's say another point now, another arbitrary point. Now this arbitrary point means that I'm choosing a point that can represent every other point. I'm not necessarily subjecting it to any condition. I'm not necessarily telling that this is the value of x and this is the value of y. For me saying this is x1 and this is y1, and I'm already fixing it to a particular value, and this one too is already a particular value, but this one is like still a variable. It's unknown, so it can be anything. So if you have this point now, then you can pair this point with this point, you still get this slope. You can pair this point with this point, then you still get a slope. So choose any 2 points that you like. So that is why we have this as well. So I can say this is y minus y1 over x minus x1. So this and this will be the same, provided that this x and y, they come from the same point. If they don't originate from the same point, then this will not be cool. Now, you see what I'm talking about now. So let's use this expression. This is the expression. If you are given 2 points, you will combine this expression with this expression to get the equation of that line. That's if you are given 2 points. But if you are given the other one that I talked about the other time, which is if you are given the slope and a point, then you combine this m. This m is the slope that you've been given. Then you combine it with this to get the equation of that line. So now I will be combining these two together. So let me clean the slope part. So what's my y2? So I'll just label this. This will be my x1, this will be my y1, this will be my x2, and this will be my y2. So x1, y1, x2, y2. So I'll have here minus 3 minus y1 is 7 all over x2 is 2 minus, and x1 is, so that's minus 2. Now this will be equal to y. Y is just arbitrary, I don't know the value. So y minus, what's my y1? Y1 is 7. Then we have x, it's also arbitrary, minus x1. What is x1? X1 is what? X1 is minus 2. So I will have minus 2 here. So let us proceed. From this place, minus 3 minus 7, that's minus 10. Then 2 minus minus 2, that will be 2 plus 2, which is what? Which is 4. Then this will be equal to y minus 7 over x plus 2. Now, what do we do here? We'll cross multiply. Isn't that what we do? Yes, let's just cross multiply. But the ideal thing to actually do here is find the LCM of these two and use it to multiply the equation 2. But you can cross multiply. So just say cross multiply. As you can see, I'm writing all the information, whatever I want to do, I'm writing it here. So you should also learn to do that too. So cross multiplying, what do I have? That means that minus 10 will be multiplying x plus 2, and 4 will be multiplying y minus 7. So I'll have 4 into bracket y minus 7 equals minus 10 into bracket x plus 2. I expect that if you are watching this, your question, you are sending them in already. Don't forget, you can use this WhatsApp number to send your question in, and I will attend to them here. So open this bracket, you have 4y minus 28 equals minus 10x and minus 20. So what do we have here? So let's just move everything to the left hand side here. So we have 4y plus 10x then minus 28 plus 20 equals 0. So we have 4y plus 10x minus 28 plus 20, that will be minus 8 equals 0. And this gives the equation of that line. Let us test maybe this equation is actually true. You know, what does this mean? This means that when x equals to minus 2, then y will be 7. And this implies that when x equals to 2, y will be minus 3. Let us test with this equation that we have gotten. So let's just pick minus 2 and see if we will be able to produce 7. So if I put x to be minus 2 in this place, so that will be 4y plus 10 to bracket minus 2 minus 8 equals to 0. This implies that 4y minus 10 that's minus 20 minus 8 equals to 0. So this implies that 4y minus 28 equals to 0. Then 4y will be equal to 28. Then by the time we divide both sides by 4, divide both sides by 4, and y will be equals to what? 7, which is what? Which is confirmed. Which is right. So we can also confirm this on your own. So now what have we learned now? We've learned how to find the equation of a straight line given 2 points on that line. All you need is 2 points on that line. So that's that about that. Okay. Let's find another question to solve. So in this year, this is 1994. I'm picking question. I'll pick question 4. I'll start from question 4A. So and other questions in this year too. So I'll pick them randomly. So that I want us to spread across all years and not be stereotyped to a particular year. So let me pick the first question that we have here. The question says divide 1. Let me count them off this without that one. 3, 6, 8. 3, 4, 5, 6, 7, 8. Base 2. Divide it by 101 base 2. Okay, so I want to divide this. I cannot divide this like this. I have to convert to base 10 first. And how do we convert to base 10? I'll show you how to do that now. So when I convert to base 10, that's when I'll be able to divide. And if the question requires me to convert it back to base 2, let's check that here. So the question does not require us to convert it to base 2, but we'll try and do that. So before you perform this operation, you have to convert it to base 10. So let me convert to base 10. And there's a trick. In case this is an objective question, it appears in the objective test, then there's a trick as to converting this to base 10 without having to write that long thing. You know, if you want to convert this to base 10, what do? You start labeling from 0. You say this is 0, 1, 2, 3, 4, 5, 6, 7. Then you label this one to 0, 1, and 2. Then you start computing a lot of things. Now, without stress, you can actually get the value of this in base 10 if it is an objective question. I'll do the theoretical part now, but let me quickly show you that. What do you do? Follow it patiently, please. What you do is that you start from the first number here. The first number here is what? Is 1. Now, what you do next is that you multiply this first number with the base. This thing will be doing it repeatedly. So when you get your result, you will add it to the next number. The result of the addition, then you multiply it again. Let me go over that again. You start from the first number, multiply it with the base. Then the result that you have gotten, you will add it to the next number. Then after adding it, that same result again, you will multiply it by the base. Then you continue that cycle until you reach this place and you stop. So let me show you what I'm talking about. So 1 times 2, what's that? That's 2. 2 plus 1, that's 3. So I got 3 here. So 3 times 2, that's 6. I'll come here. 6 plus 1, that's 7. 7 times 2, that's 14. Then 14 plus 1, that's 15. 15 times 2, that's 30. 30 plus 1, that is 31. 31 times 2, that is what? 62. Then 62 plus 1. I hope we have not reached. So let's start over again. Let's be marking it as we are doing it. So 1 times 2, that's 2. We are done with this one. 2 plus 1, that's what? That's 3. So 3 times 2, that's 6. Then 6 plus 1, that's 7. So 7, then we have 7 plus 1. Okay, 6 plus 1 is 7. 7 times 2 is 14. So we have 14 plus 1 now. 14 plus 1 is 15. Then 15 times 2 is 30. 30 plus 1 is 31. So 31 times 2, that's 62. 62 plus 1, that's what? 63. So this one 2 is gone. So 62 plus 1 is 63. Then 63 times 2, that's 126. 126. So 126 plus 1. That's 127. Then 127 times 2, what would that be? 127 times 2, that should be 254. 254. Then at the end of the day, we had this one, that would be what? This one will now be what? 254 plus 1. So that would be what? 255. Now, once you add that last number, last digit, you don't have to multiply by this again. Now, let's see maybe this will work. You know the normal process. If it is in a theory case, you pick each of this number, multiply it by 2, and 2 will be raised to this power. So we have something like 1 times. So we have something like 1 times 2 raised to power 7 plus 1 times 2 raised to power 6 plus 1 times 2 raised to power 5. Now I'm still repeating the 2 raised to power 7, 2 raised to power 6, 2 raised to power 5. Now it's still the same base we'll be repeating. The only thing that will be changing there is this 1, but we have 1 all through here, so we don't have anything to worry about. And the power square will be descending like that for 2. So we are on 5 now. So let's move forward. We have plus 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to 2, 1 times 2, you have 2 raised to power 1, and lastly 1 times 2 raised to power 0. So if you agree with me very well, this is 2 raised to power 7. What is 2 raised to power 7? 2 raised to power 5 is 32. So 32 times 4, that should be 128. 32 times 4. So that's 8. 128. Yes. So that's correct. So we have 128 plus 2 raised to power 6. That's 32 times 2. That's 64. That's 64 plus 2 raised to power 5. That's 32 plus 2 raised to power 4. That's 16. Then next is 2 raised to power 3. That's plus 8. Then the next one we have 2 raised to power 2. That's 4. Then lastly we have 1. So we have 1 times 2. That's 2. Then from here we have 1 times 2 raised to power 0. 2 raised to power 0 is 1. 1 times 1 is what? Is 1. So let's see how it goes. Now 128 plus 64. We can use our calculator to do this. I have my calculator here, so you can bring out your calculator. Now, I will urge you in your exam tomorrow, don't prove that you can do calculation offhand. That's why you are giving calculator. Use your calculator. Press anything. Even if it is 2 times 2, press it. Be sure that you are right. So let us use our calculator to confirm this. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and then plus 1. So that is, from a calculator here, it is 255. So you can also confirm that on your calculator, which is what? 255. As you can see, which is the same thing with what we got now. Now it will be easier for us to check using this one that is very, very small. So let's go with the same process again. 1 times 2, that's what? 2. Then 2 plus 0 is 2 again. So we will still say 2 times 2, that's 4. Then 4 plus 1, that's what? That's 5. Which means that this thing will be 5 in base 10. So let's do it using this approach. Let me just create the column here. So here we'll have 0, 1, 2, right? So that's 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. So what do we have here? 1 times 2 raised to power 2, that's 4 plus 0, then plus what? 1 times 1, 1, which is what? Which is 5. As you can see, it will not fail. So you can always use this other method that I just taught you now. You can use it for objective questions. So what are we supposed to do exactly? We're supposed to divide this by this. So we will now have 255 divided by 5. And how many times will 5 go in this guy? That will be 51. So 5 divided by this is what? 51. So let me confirm that with my calculator here. 255 divided by 5. That's 51. So the next thing we want to do now is that we want to convert back to base 2. Since the question was given in base 2, but we got our answer in base 10. So let's convert back to what? To base 2. So 51 is our answer. We are converting to base 2. I believe I can rub this off now. So I'm going to rub this. So now I'll advise you, in case I'm rubbing anything off too fast, you can always screenshot so that you check later. Your phone is smart that way. So screenshot the screen, then you go back and check it later. Now, if anything is not clear as well, you can also comment in this live video. If anything is not clear, if you have joined us already and anything is not clear that I'm doing here, you can comment below, then I will attend to it. Don't forget to tell your friends and your classmates to join this live video as well. So 51. So we want to convert 51 to base 2. So you know how we do that. We just draw a table. So 51. Then what we use to divide all through is 2. So we say 2 in 51, that's 25. It will remain 1. 2 in 25, that's 12. That will remain 1 as well. 2 in 12, that's 6. That's remain 0 because there's no remainder. And 2 in 6, that's 3 remainder 0. 2 in 3 is 1, then it will remain 1. 2 in 1 is 0, it will remain 1. So we write the number from here up. So we have 1 1 0 0 1 1 base 2. So that's 51 in base 2. Let's confirm if that's actually true using our method. 1 times 2 is 2. 2 plus 1 is 3. 3 times 2 is 6. 6 plus 0 is 6. 6 times 2 will be 12. 12 plus 0 is still 12. So 12 times 2 is 24. 24 plus 1 is 25. 25 times 2 is 50. 50 plus 1, 51. You can see that's very, very, very correct. So that's that about that question. Let's move to another thing, as I'm expecting you to send in your questions. So let's do something challenging now. Let's do something challenging. So this question is on longitude and latitude. Longitude and latitude. It's still the same year, 1994, question 12. Question 12a. It says 2 points x. We're given the coordinate of that point. So we have point x, which is 32 degrees north and is 47 degrees west. And another point, the second point, which is point y, is 32 degrees north and 25 degrees east and 25 degrees east. So they are on the Earth's surface. If it takes an aeroplane 11 hours to fly from X to Y, so time taken for the aeroplane to fly from X to Y is 11 hours. Along the parallel of latitude, calculate its speed. Let's calculate its speed. Speed is what we are looking for. Calculate its speed correct to the nearest kilometer per hour. And we're given there that the radius of the Earth, our big R is 640 kilometer. 640 kilometer. And we're given pi. Our pi to be used is 22/7. 22/7. Now, this is a question of longitude and latitude. Now, what we do is that let us sketch our longitude and latitude. So we have a sphere. That is representing the Earth. This is the sphere that is representing the Earth. Of course, we have our GMT and we have our equator. So let us locate these 2 points. Point X is 32 degrees north and 47 degrees west. So this is like north, east, west, and south. So 32 degrees north, we can find that somewhere around here. So we can say this is what? 32 degrees north. Then 47 degrees west, that's this side. So let's say this is the 47 degrees west. 47 degrees west. So this place like this point as it is now is point X. The point where this longitude and this latitude meets. Now let us locate the other point y2. Point y2 is on longitude 32 degree north, but in this case now is 25 degree east. 25 degree east. So this is 25 degree east, and this point, where is that? This point now is point y. Now what we need to do now is that let's construct something here. Let's construct something here. The one is on the east side, one is on the west side. So we can have this, tracing them to the center like that. From this place now, this is like an arc. This figure here is like an arc. And that is why all we just need to do here to find the distance, we are looking for the speed. And speed is equal to what? Distance over time. Take note of that. Speed is equal to distance covered over time taken. So which implies that I already have my time taken, which is 11 hours. Which implies that if I'm going to get the speed for this, I need to get the distance covered. And what will be the distance covered? That will be the length of the arc that was passed through. The length of this arc. So if I can find the length of this arc, then that will be the distance covered by the aeroplane. So now, before I can find the length of the arc, I need the angle. I need the angle that this arc is making. So what angle is it making? Let's see how we do that. Now, as you can see, this 32 degree Newton and 32 degree Newton, both of them are common. But if you look at this and this, they are the ones that are not common. So for the one that is common, you keep it that way. That's not what we are interested in. That's not what will give you the difference in the angle. But this 47 degree and 32 degree is what will give you the thing we are looking for. Now, if there are two cases that can happen here, of course, you have one of them to be equal. It can be the longitude that are the same, or the latitude that are what? That are the same. So if it is longitude that are the same, like for instance, 32 degree Newton and 32 degree Newton are the same, you don't have any business with that. Now, for this other part that are not the same, is that they are on the same side? I mean, is that this one is on the west side and this one too is on the west side, or this one is on the east side and this one too is on the east side, or you have a case whereby they are on different sides as we have here. If they are on different sides as we have here, what you do is what you will add, because by the time if we this GMT here, we consider it as 0. We consider it as 0. Let me draw what we have there so that you can have a better view of it. So this is the point where the arc comes from. This is the arc that we're talking about. Now, from this 0 to this left hand side, this is 47 degrees. Now, from this 0 to the right hand side, that's the what? That's the 25 degrees. So in this situation, now by the time we want to find the total angle that we have here, that will simply be what? 47 plus 25 degrees. So that's if they are on the same what? If they are on the same side. Now let me quickly chip this in. Let's say they are not on the same side. Let's say, if they are on different sides, west and east. But if they are on the same sides, like that is west and west. So let's say we have 47 degree west and 25 degree west. Let's see what will happen there. Now, both of them will fall on this place. That's what will happen. So the first one will fall here and the second one too will fall here. So if I draw that very well, we'll have our GMT here. Then one will go like this. Then another one will go this way. So we'll have our arc towards here. Which implies that this place will be 47 degrees. And this small part will be what? 25 degrees. And what angle are we interested in? We are interested only in the angle that is here. Since this entire angle here is 47 and this other one is 25, so all we have to do is what? Remove 25 from what? 47, then we'll get the angle that is here. So what we do is that if they are on the same side, if we have west-west or we have east-east, then you subtract the smaller from the bigger. But if they are from all different sides, one east and one west, and if it's the other way around, maybe let's say these are common, maybe we have 47 here, and these ones are the ones varying. So if it is north and south, you add, and if it is north, you subtract, or south, you subtract. So let's solve this question that we have here with us. So now that we know the angle, so to find the distance will be the the angle, let me call it theta, over 360 degrees multiplied by 2 pi r. That's the big R, the radius of the earth. I will be given that. So this will be, what's the angle? We said we'll add 47 with 25. If you add 47 and 25, what do we have? That should be 72. So let's confirm that. 47 plus 25. That's 72. So we have 72 all over 360 degrees multiplied by 2 multiplied by pi has been given as 22 over 7 multiplied by 640 kilometers. So let us perform this now. Now, like I said the other time, your calculator is meant to make work easier for you. This is not jam, this is WAEC. Press the calculator, press it here. So let us press this. Don't be using your head to do all these things. It's only in jam that too much of pressing the calculator can waste your time. But in WAEC, or you have, and that doesn't mean you should sleep on a question. So just press this calculator. So we press the numerator 72 times 2 times 22 times 640. 72 times 2 times 22 times 640. So I write this here. This will be 2027520. So that's like 2,027,520. So all over 360 times 7, 360 times 7 now, which is 2,520. So at the end of the day, we'll have 2,027,520 divided by 2,520. So that is 804.571 kilometers. So that's the distance covered by the aeroplane. So after finding the distance covered, don't forget what we have to look for exactly is the speed. And we said that what? Speed equals distance over time. So all we have to come and do here is speed will now be equal to 804.571.571. You don't say that when you're calling numbers after the decimal point. It's not 571. It's 804.571 over what's the time given? The time taken is 11 hours, and the speed is required to be calculated in kilometers per hour. So we don't have anything to convert. So divided by 11 now. So when we divide this by 11, we have 804.571 divided by 11. So that would be 73.1428 kilometer per hour. So let's see, the question wants us to correct to the nearest whole number. It says, correct to the nearest kilometer per hour. So if you want to convert this to the nearest kilometer per hour, what do? We go to the last, before we go to the number immediately after the decimal point here. What's the number? That's 1. Is the number up to 5? No. If it's not up to 5, then we'll round it up to 0 and add it to this. So this will be what? 73 kilometer per hour. And that's the speed with which the aeroplane moved from point X to point Y. So that's something on longitude and latitude. So, like I said, in case you want to visit any of these things later, learn to screenshot. You can just screenshot your screen right now and you visit that later. So I'll give you 3, 2, 1 to do that. So let's find another question to solve. So I think we've done something from 1994 already. So let's find another year to go. Just click randomly and go to another year. Theory, question. Let's do something on indices this time around. Indices. Now you can also comment whichever area you want me to be picking questions from. Like if you want me to pick question from simultaneous equation, just comment simultaneous equation. If you want me to pick question from solve, just comment. Or if you have your own question, that's the number there. Send your question. Okay, I think we have a question here. Okay. Somebody sent us one of matrix, differentiation, integration, logarithm, graph. Okay. So we have matrix, differentiation, integration, logarithm, and graph. Well, I don't have any problem with everything that is here, but the graph problem might be a little. So I'm just in because I don't have a graph here to explain a lot of things. So, but matrix, differentiation, and integration and logarithm, those ones are. Let me start dealing with them now. Okay, but I think it's in the WAEC now. It's the major mathematics now, not. So, but I learned that I checked the textbook recently. I see that all these topics are actually in general mathematics now, but they didn't really go in depth like that. Now, let me give you some. Let's start with matrices. Matrices is just a rectangular arrangement of numbers into rows and columns. I also advise you after this live session, you can subscribe to our YouTube channel, Science Ignite Africa, or you log into our website. There are lectures on matrices already there, so you'll be able to get more details. So for any matrix, it's always rectangular. It's always rectangular. You can have a matrix of this nature: 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have rows and we have columns. This matrix that I've put here now is a squared matrix. A squared matrix. Why? Because the number of rows and the number of columns, they are the same. Now let me teach you how to know rows and let me teach you how to know columns. Now, as I'm walking through this line now, horizontal. If you move horizontally, then you're talking about rows. So this first horizontal line is the first row. This second horizontal line is the second row. And this third horizontal line is what? Is the third row. But for columns are vertical. So elements that you can find on the vertical, they are what? They are elements that belong to a column. So this is a single column. This vertical place is a single column. This another vertical place is a what? Single column as well. Now another vertical place there is a what? A single column. So this is first column, second column, third column. So we have 3 rows and 3 columns here. So this is what? A 3 by 3 matrix, which is what? A squared matrix. But we can have other dimension of matrices too. We can have 2 by 3. Those ones are not square. That is, the number of rows is not the same with the number of what? With the number of columns. So that's that about rows and columns. Now, before you can add or subtract, because one of the things that you can be asked in your question is, you can be asked to sum matrices together, or you can be asked to subtract matrices from each other. Now, before you can add or subtract matrices, the matrix must be of the same dimension. What I'm trying to tell you that you cannot add a 2 by 3 matrix with a 3 by 2 matrix. They are two different things entirely. If you have 2 by 3 matrix and 3 by 2 matrix, their addition is impossible. The addition is what? Impossible, because this one has 2 rows and 3 columns, but this one has 3 rows and what? 2 columns. So the addition is not possible. So one of the first things that you must take note before you can perform addition or subtraction in matrix is that the dimension must be the same. So let's give ourselves an example now. If I have 2, 1, 4, 6, 3, 0. Let this be matrix A. And let matrix B be 5, 2, 6, 1, 1, 2. Now, the person that sent in the message that we should revise matrices and all those things, you can send in your questions on any question that you have been solving that you find difficult. You can send them in now, so that by the time I finish this illustration, then we cannot. Now I'm treating matrix now. I'm expecting that before I finish all this illustration, then you should be sending your questions on matrices in, so that I'll be able to any question that you have met in your maybe textbook or your past question, just send them in so that I can solve it for you now on matrices. Then we'll talk about integration, we'll talk about differentiation too. So for this now, how many rows do we have? first row, second row, third row. So we have what? 3 rows. And how many columns? 1 and 2. So we have 2 columns. So this is a 3 by 2 matrix. And as you can see, without even stressing ourselves, this is also the same, have the same dimension. So addition can take place between them. So if I want to add both of them now, I will have A plus B will now be equal to. So it's addition and subtraction, they are the simplest of all. All you have to do is mind the position. Mind the what? Mind the position. So if you can consider the position, okay, this one is at, let me just use something general now, not something, not a term in matrix. Let's say this is top left corner. This is top left corner. If you look at the top left corner here, what do we have here? We have 5 here. So which implies that I'm going to be adding these two together. You don't have to deal with every other part. This one is at the bottom right corner. So this one is at the bottom right corner. For instance, now these two here, very soon I will teach you how to locate the numbers using row and column. Now this one here, these two here, belongs to row 1, column 1. Is the element that belongs to row 1 what? Column 1. Now this one here, which row does it belong to? It belongs to row 2 and column what? Column 2. So this belongs to what? Row 2, column 2. So what I'm trying to say now is that for addition, elements that belong to row, the element that you find at row 2, column 2 in the first, is the element that you had with the one that is in row 2, column 2 in the second as well. Nothing must change. So I'll just add this 2 plus 5, that's what? 7. 1 plus 2, that's 3. 4 plus 6, that's 10. 6 plus 1, that's what? That's 7. 3 plus 1, that's what? That's 4. Then 0 plus 2, that's what? That's 2. With this, we are done adding. If you want to subtract 2, it is the same way. A minus B equals, so 2 minus 5, that's minus 3. 1 minus 2 is what? Minus 1. 4 minus 6 is minus 2. Then 6 minus 1 is 5. 3 minus 1 is 2. 0 minus 2 is minus 2. So that subtraction, you can see it's very, very, very simple. Now, another way they can make it complicated is, for instance, now I can say you should compute, let me write it here, 2a minus 3b. Yes, I can ask you to compute something like this, 2a minus 3b. So it's not just ordinary a minus b again. I've added some things to it. It's very, very easy. It's just like you are opening a bracket. That's it. In fact, a lot of things we'll be doing in matrix is just like you are opening a bracket. Once you just calm down and listen to it very well, you realize that it's just the normal opening of brackets. Even multiplication of matrices, that seems to be very, very difficult for people. It's just like you are opening a bracket. Just calm down as I will explain everything very soon. So for this 2a now, all you have to do is what? Multiply every number here by 2. Then this matrix will change from A and will become 2A. So let's see. I believe this one is already clear. So let me proceed to this thing I have at top here. So if A is this, then 2A will be everything in A multiplied by 2. So 2 times 2 is 4. 2 times 1 is 2. 2 times 4 is 8. 2 times 6 is 12. 2 times 3 is 6. And 2 times 0 is 0. Then 3b equals 3 times 5 is 15. 3 times 2 is 6. 3 times 6 is 18. 3 times 1 is 3. Then 3 times 1 again 3. And 3 times 2 is 6. So the next thing I will do now is I will now compute my 2a minus 3b. So computing 2a minus 3b now, I have 4 minus 15, that's minus 11. 2 minus 6, that's minus 4. 8 minus 18, that's minus 10. 12 minus 3, that is 9. That is 9. 6 minus 3, that's 3. Then 0 minus 6 is minus 6. So as you can see, that's that. Okay, so we might have a short break and we'll come back.